projectile motion, initial velocity is not equal to 0. The motion of a particle along a circumference of circle with uniform angular velocity is called uniform circular motion. We need two x as well as y axes to describe the motion of the body here. That is why projectile motion is a two-dimensional motion where we are taking two axes to describe the motion of the object. Hello everyone, welcome back to the last session of Chapter 4, Motion in a Plane. I am Nishmananjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So, in today's session, we shall discuss what is projectile motion and solve a numerical, and also we'll try to understand what is uniform circular motion and centripetal acceleration. So start with the last session, session 5 of chapter 4, motion in a plane. First, we'll look at what is projectile motion. What is projectile motion? If you can recall our previous session where we had discussed three types of motion based on the frame of reference. Three types of motion based on frame of reference. That is one dimension, two dimension and three dimension motion. In one dimension, we just consider a motion of the object along a straight line. If in case we have a car moving along a straight line, the motion of the car along a straight line, or motion of the ball along the straight line. So all these are motion in a straight line, that is motion in one dimension where only x-axis, only one among the three coordinate axes, that is x-axis, is sufficient to describe the motion of the object. And also we had studied the freely falling body in the previous session where we dropped the ball from certain height. Consider this is the building. A man is standing on the building and he will drop a ball to the ground. He will drop the ball to the ground in the vertically downward. A boy is dropping the ball vertically downward, standing on the building at certain height. So, in this freely falling body, u is equal to 0. U, initial velocity, is equal to 0 for a freely falling body. When you study projectile motion, the projectile motion, u is not equal to 0. In projectile motion, initial velocity is not equal to 0. And what is two-dimension motion? We need two axes, that is two among the three axes, so x and y axis, to describe the motion of the object. So we had seen the example for two-dimension motion is nothing but projectile motion and also uniform circular motion. These are the motion in two dimension that we need two axes, x and y axis, to describe the motion of the object. And the third is three-dimensional motion where we need all the three axes to describe the motion of the object. A bird flying in a sky, in a space. So all these are motion in 3D where x, y and z axis is required to describe the motion of the object. So in today's session, we shall study what is projectile motion, what are the components of projectile motion. We shall try to understand what is projectile motion and what are the components of projectile motion. So what is projectile motion here? Projectile motion is nothing but motion in two dimension. That is nothing but we need two axes, that is x and y axis, to describe the motion of the object. So projectile motion is the example for two-dimensional motion. So here in projectile motion, let us first try to understand what is projectile motion. Then we'll analyze what do you mean by the terminology projectile. So in projectile motion, look at here. A boy is kicking a football. It is following a path and it is reaching back the horizontal axis. When a boy kicks the football, it is not just going along the vertical axis. It reaches the maximum height and it is again coming back to the horizontal axis. You can see both x vertical axis and Y, that is both Y axis, vertical axis, and X, that is horizontal axis, is describing the motion of the football that's kicked by the boy. This is the trajectory, this is the path followed by the football to reach the horizontal axis. Similarly, you can see the diagram here. It is very important to understand the description, the detail about the projectile motion, because we next have to derive the expression to prove that the path, the trajectory followed by a projectile is a parabola. We'll come to that. Here you can see, first you can see a body or object is initially at origin. I am standing on a horizontal platform. This is my x-axis, and I will throw a ball. I am standing on the horizontal axis. I will throw a ball. To throw a ball, what I need? I need to apply some initial velocity u. Initial velocity given by u. I'll apply, what is the condition? I'll apply certain initial velocity. I will stand on the horizontal axis. I will throw the ball. So, initially, I applied some initial velocity. Now, the ball is moving. Firstly, you can observe two kind of motion here. Firstly, the ball is moving along vertical direction. The ball or the body is moving along the y-axis. That is, ball is moving vertically or body is moving vertically. Then it reaches a maximum height. At this point, say A, and then the ball reaches back to the horizontal axis, making an angle theta. With the horizontal axis. So, I will consider a body. I am standing on the horizontal axis. This is my x-axis. I will apply some initial velocity u in order to move the ball. Or a body. I'll apply some initial velocity and I'll throw the ball into space. To throw the ball into space, what I need? I need to apply some initial velocity u. When the ball or a body travels, it first travels in the motion of the body is along vertical axis. That is, the motion of the ball is along vertical component. Then it reaches a maximum height and it returns back to the horizontal axis, which is defining angle theta. This is what we have written here. An object is thrown into space. With an initial velocity at an angle. So, a body is thrown into space. To throw into space, I am applying some initial velocity. This initial velocity is also called velocity of projectile. Initial velocity is also called u, is a velocity of projectile at an angle to the horizontal direction. It's making an angle theta to the horizontal direction. This angle is also called, this angle theta is also called angle of projectile. So, horizontal direction, and then allowed to move in 2 dimensions under the action of gravity alone is called projectile. Under the action of gravity alone is called projectile. So, I am throwing the ball. I am standing on the x-axis. I am throwing the ball into space. What is the condition? For a body to move, I am applying initial velocity, which is also called velocity of projectile. So, I will apply an initial velocity u. So, the body will move first along the vertical component, then it reaches a maximum height at certain point, and then the body again comes back to the horizontal component, that is x-axis, making an angle theta. So, you can observe 2 type of motion, body's motion along vertical component and body's motion along horizontal component. So, I need 2 components, that is vertical component and horizontal component to describe the motion of the projectile. That is why we say we need 2 x as well as y axis to describe the motion of the body here. That is why projectile motion is a 2-dimensional motion where we are taking 2 axes to describe the motion of the object. So, this is what we call projectile motion. So, what do you mean by the term projectile then? Projectile motion, we got to know the both vertical component and horizontal component is describing the motion of the body or the ball. That's why it is called projectile motion. Then what is the terminology projectile? What do we call projectile? What are the components it requires to be called as projectile? That we'll look here. I said, where am I standing? I'm standing on the horizontal component. I have a ball in my hand. I'll throw it into space. To throw it into space, what is the condition? I need to apply initial velocity, that is velocity of projectile u, in order to move the ball from the origin O. When I applied initial velocity, first the body moved along the y-axis vertically, then it reached the maximum height, then the ball came back to the horizontal component, that is x, defining an angle theta, which is called angle of projection. Angle of projection. When this ball is traveling in the vertical axis, it cannot go in the vertical axis itself, because in every point of the motion of the ball, in every point of the motion of the body, there is the action of gravity. There is the action of gravity. It can move vertically. At some point, due to the action of the gravity, it has to reach maximum point and come back to the ground, that is horizontal axis. That is why, due to the influence of gravity, the ball reaches a height, maximum height, and it comes back again to the horizontal component. That is what is written here, gravity alone. So there is action of gravity. When the body moves along, you can see a path is traced by the ball or a body. A path is followed by the body. This path of trajectory, this path is called trajectory, and it is called a parabola. In mathematics, we'll detailedly study what is parabola. Next, we'll derive the expression to show that the path followed by the ball or the path followed by the body, that is the trajectory, is parabola. We'll prove that mathematically. So path followed by the body is a parabola. It is a parabola. And the highest distance traveled in the y-axis is called h max. H max, it reaches the maximum height. The highest distance traveled by the body or the ball along y-axis is given by h max, and the largest or maximum distance traveled by the body or the ball along x-axis, along horizontal axis, is called as range, is given as range R. So next we will resolve the component, that is initial velocity u. We have learnt about resolution in our previous session. What do you mean by resolving? That is nothing but splitting up or dividing the component into its respective, components along x and y axis, that is resolving. So we'll resolve this initial velocity u into its respective component along x axis and along y axis. So with respect to theta, the component along x axis is always cos theta, So initial velocity is resolved into u cos theta along x axis, along horizontal axis, and the initial velocity u is resolved into u sin theta along y axis, that is vertical axis. I have resolved initial velocity into its respective components along x and y axis. And here in the diagram you can observe, at each point when the ball is following the trajectory, at each point, this is your vertical component, this is your u sin theta, and this is your u cos theta. It is parallel to x-axis. This is your u cos theta and u sin theta. And when it comes to here, you can see when it reaches the maximum height, your final velocity v will become 0. When it reaches the maximum height, when the body reaches maximum height, final velocity v at h max will become 0. And you can see there is no vertical component, there is only horizontal component. Ma'am, I have only horizontal component. So can the body or the ball move only straight in the horizontal way? No, because there is the action of gravity in each point of its motion of the body. So it has to come back to the x-axis. So again, when you compare here, you can see this is your u sin theta, this is your u cos theta. So u cos theta, u cos theta, u cos theta, it is always, you can see, it is constant. It is constant. The horizontal component is constant at every point on the trajectory. So at the horizontal component, A is equal to 0, because along the horizontal component, you can see the ball, it is constant. You can see u cos theta, u cos theta, u cos theta, parallel to x-axis. There is no change. There is no change. So it is moving constantly. So with a constant velocity. So A is equal to 0 in horizontal component. Whereas you can see u sin theta, that is vertical component, the body at velocity is at each point of the trajectory, it is changing. Here you can see u sin theta, here it is becoming 0, and here you can see it is reverse direction u sin theta. So at each point of the motion of the ball in this trajectory, you can see the vertical component, that is u sin theta, the velocity is varying. So along, you can see if the ball is thrown up due to gravitational force, it will pull back. So A is equal to minus G. We had studied this in the previous session. So for a vertical component, A is equal to minus G, and for the horizontal component, since it is not changing, the velocity is not changing, the initial velocity, you can see it is not changing, it is constant throughout each point on this trajectory. So A is equal to 0 along horizontal x-axis. So this explanation is very important to derive the expression where we have to prove the trajectory followed by the body or the ball is parabola mathematically. So I hope you have understood what is projectile. So this is what we call as projectile, that we are standing on the x-axis, that is horizontal component. I have a ball, I have a body, I'll apply some initial velocity. First condition is I'll apply some initial velocity. I'll throw the ball along the vertical axis into space. So it first moves, I'll throw it into space. So first it will move along the vertical axis, then the ball reaches the maximum height, then it comes back to the horizontal component, defining the angle theta, Then you can see here, the highest distance travelled along y-axis is h max. The largest maximum distance travelled by the body along x-axis is called range r. And we have resolved the initial velocity into its respective components along x-axis, that is u cos theta, and along y-axis it is u sin theta, resolving the initial velocity. And the path followed by the ball, the trajectory followed by the ball, it is a parabola. Then you can see the velocity, it reaches the maximum height, it is 0. Then at each point of velocity, the vertical component, it keeps varying. Whereas in the horizontal component, you can see it is constant. That is why A is equal to 0. This is what we call projectile. And its motion in 2 dimensions, that is we need x and y axis to describe the motion of the projectile, that is called projectile motion. To call it as a projectile, these are the components required to call it as a projectile and projectile motion. And you can see here the example for projectile: a cricket ball thrown up, a stone thrown from the ground. All these are the example. The path traced by the projectile is called its trajectory, and it is called as a parabola. That trajectory is called as a parabola. Next, we have expression. We have to derive expression for trajectory of a projectile. We have a trajectory of a projectile, and we have to prove it is a trajectory is a parabola mathematically. You can see the same diagram that we have here, the same diagram that I have written here. So what first I have to do is I will consider the motion along y-axis. First I'll consider motion along y-axis. First I'll consider the motion of the projectile along y-axis. I need two components to describe the motion of the projectile. One is motion along y-axis, vertical component, and next motion along x-axis, that is horizontal component. When I say motion along x-axis, I will write S is equal to y. The distance travelled by the projectile. It's not the highest or maximum distance I am talking about. It is just the distance travelled by the projectile along y-axis. That is why S is equal to y. And what is its velocity along y-axis? It is resolved into u sin theta along y-axis. And I know along y-axis A is equal to minus g, because when you throw up the ball, the gravitational force is acting downward. So, it is A is equal to minus g, because in the y-axis, the motion of the projectile, the velocity is not constant. It is varying at each point of the object's motion. That is why A is equal to minus g, and the time for travel is given by t. So, these are the conditions. Now, I want to know the displacement of the projectile along the y-axis. So, what is the displacement? So, I will consider the second equation of motion. We had discussed in the previous session the second equation of motion. What is the second equation? S is equal to ut plus half at square. So, this is the expression that I have considered, the equation of motion that describes the displacement, that gives the displacement of the projectile along y-axis. So, I know the distance travelled by the object along y-axis, S is equal to V, S is equal to Y, that is equal to, what is the velocity along y-axis? It is u sin theta into t plus half, what is A? Minus g, t is t square. So, what you will get? You will get u sin theta t minus half, minus plus is minus half gt square. So, this is your y, this is your y, this is your equation 1. Consider this as equation 1. So, this is the equation that describes the motion of the object, projectile along y-axis, consider as equation 1. Similarly, now I want to know the motion of the object, motion of the projectile along x-axis. So, secondly, I want to know the motion of object, along x-axis. So, what will be my consideration? S, the distance travelled by the body along x-axis is S is equal to x. Its velocity, component of velocity along x-axis will be u cos theta. And I know along the horizontal component, it is constant at all point. A is nothing but equal to 0, and the time is nothing but taken by the projectile to travel is t. Similarly, in the x-axis, how will I calculate the distance? Distance is given is equal to speed into time. What is speed? Distance by time. So, distance is equal to speed into time, because A is 0. A is 0. So, I have taken distance is equal to speed into time. So, what is the distance travelled along x-axis? It is x. Speed is nothing but velocity. Velocity of the projectile along x-axis. It is u cos theta into t. It is u cos theta into t. Consider this as my equation 2. Equation 2 describing the motion of the projectile along x-axis, along horizontal component. So, here I can get the value of t now. I want t. What is t? Bring the cos theta down. It will be u cos theta. U cos theta. I got what is t? T is equal to x by u cos theta. Substitute the value of t in equation 1. Substituting the value of t that I have got from the equation 2 in equation 1. So, what will my equation 2 reduces to? Y is equal to u sin theta t. That is u sin theta. What is t? What is t? It is x by u cos theta minus half g What is t square? What is t now? X square, multiplying the square, x square, u square, cos square theta. Substituted the value of t in equation 1. Now you can see this equation is similar to the equation of parabola. So this equation is similar to the equation of parabola. What is the equation of parabola? It is, from mathematics, you learn this in your higher school, in your higher classes, that equation of parabola is nothing but y is equal to ax plus bx square. Isn't this similar to this equation? You can see ax plus bx square. You can further simplify this equation too. You can see u gets cancelled. What is sine theta by? What is sine theta by cos theta? In trigonometry, it is tan theta. Substitute that. U is cancelled. It is nothing but x tan theta minus half g bx square. So this term, there is no further substitution. It remains as it is. X square, I multiplied square inside. It is u square cos square theta. Isn't this equation similar to y is equal to ax plus bx square? So a here is what? A is nothing but your, it's nothing but your tan theta. A is your tan theta, because x, what is remaining? A is equal to tan theta. Bx square, x square is there. What is b here? Then b is equal to minus half g by cos square theta. So this is the equation of parabola. This is minus ax minus bx square. This is minus ax minus bx square. This equation is similar to this equation, right? Where x, what is your a? A is tan theta, minus, so this will be plus here, minus, x square, you have x square there. What is remaining? B is equal to half plus half g by cos square theta. So this is a value of A and value of B. Ax minus bx square theta is similar to this equation. Hence, mathematically we have proved the path traced by the projectile. The path traced by the projectile is a parabola, because it is similar to equation of parabola ax minus bx square. Hence, we have proved the trajectory of projectile, that is path traced, is nothing but a parabola. This is the expression. Ax, A is what? Tan theta, minus b x square you have there. What is b then? It is plus half g by cos square theta. So this is the expression for trajectory of projectile. Next, we shall discuss the 3 parameters of a projectile. 3 parameters. One is maximum height, one is time of flight, and third is range of a projectile. So 3 parameters. First, we'll discuss maximum height of projectile. That is nothing but h max. So, maximum height of the projectile. We know maximum distance travelled by the projectile along x-axis. What is that? That is S is equal to h max. Now, I am talking about the maximum distance travelled by the projectile along y vertical component, that is h max. So, component of velocity along y-axis is u sin theta, and I know when we reach the maximum height, what will be the final velocity? It is 0. And what is A? A for y-axis, for the vertical component, it is minus g. Now I have to derive the expression which is independent of time. So I have A, I have V, I have initial velocity, I have x. I will consider the third equation of motion, which is that u square is equal to v square is equal to u square plus 2as. Substitute the value. What is v square? It is 0 is equal to u square sine square theta plus 2. What is a now? Minus g. What is s? Maximum distance along vertical component. It is h max. So I'll get it like u square sine square theta minus 2g h max. So bring this to LHS. So it is u square sine square theta remains as it is. This will go to RHS. So it will become plus 2g h max. So I want to know what is the maximum height. Then it will be h max is equal to u square sine square theta by 2g. This is the equation to calculate the maximum height along the vertical component. Similarly, I have to know what is the second parameter, time of flight. What is time of flight? It is the overall time taken by the projectile to complete one parabolic path. It is the total time taken by the projectile to complete one parabolic path. That is time of flight. Consider if you have in the diagram you have x and y axis. This is your trajectory of the projectile, that is a parabola from the origin. So this is the maximum height h max. So a projectile is moving from the origin with some initial velocity u. A projectile is moving from the origin with some initial velocity u. So it is taking time ta to ascend. Projectile is moving with some initial velocity. So time taken by the projectile to ascend is ta. It reaches the maximum height, then it starts to come back to the horizontal component. The time taken by the projectile to descend is td. So your total time of flight is ta plus td. Time taken to ascend, time taken for a projectile to ascend plus time taken by the projectile to descend. So that is the total time taken by the projectile to complete one parabolic path. So that is what we are discussing here, time of flight. For time of flight, what is the consideration you have to take? So your initial velocity, we are considering initial velocity. So your initial velocity is nothing but u sine theta. So along the y axis, and a is equal to minus g, and time is equal to ta. Time is equal to ta, and what is left? Final velocity at the peak, it is v0. Now I have u, I have a, I have time. With respect to time, I have to obtain the expression. So I will consider the first equation of motion. V is equal to u plus at. V is equal to u plus at. What is the final velocity? 0. Initial velocity is u sine theta minus, what is the gravitation? It is g. What is time? It is ta. What is time? It is ta. Now shifting the term, u sine theta be here, take this to other side, it will be gta. I want to know what is ta. So ta, time to ascend, is nothing but u sine theta by g. So time taken to ascend is equal to time taken to descend. Time taken to ascend is equal to time taken to descend. We will study that in detail in the upcoming chapter. Ta is equal to td. So what is the total time? I want to calculate time of flight t. So what is total time? ta plus td. If ta is equal to td, then td is also u sine theta by g. I have u sine theta, I have u sine theta by g. So t is equal to ta plus td. So what is my time of flight? Equation for time of flight. It will be t is equal to ta plus td, u sine theta by g plus u sine theta by g. It will be 2u sine theta by g. So this is the equation to calculate time of flight of a projectile. So next, the third component, it is range. I want to calculate the range r. Range r. I want to calculate what is the range of the projectile. So range is given by horizontal speed into time. So r is equal to, what is the horizontal speed? Horizontal velocity of the projectile. It is u cos theta into time is nothing but time of flight. Time of flight that you have got 2u sin theta by g. So on multiplying, what is cos theta into 2 sin theta? It is sin 2 theta. From the trigonometry, we have cos theta into 2 sin theta. That is nothing but equal to sin 2 theta. On substituting, you will get u sin 2 theta by g. You will get u and you have u. So it will become u square. Cos theta into 2 sin theta. Cos theta into 2 sin theta. What is that? That is sin 2 theta. U into u. So u into u is u square sin 2 theta by g written as it is. So this is the range. This is the range to calculate the range of the projectile. R is equal to u square sin 2 theta by g. So you got to know what is the maximum height, time of flight, you have range. Next I have a numerical which has to be solved by you. So try to solve this numerical. You got to know what is the equation to calculate maximum height. What is that? H max is equal to, what is the maximum height? How will you calculate? H max is equal to u square sin square theta divided by 2g. U square sin square theta divided by 2g. U square sin square theta divided by 2g to calculate maximum height. What is the formula to calculate time of flight? T. It is 2u. What is it? 2u sin theta by g. It is 2u sin theta by g. What is the formula to calculate horizontal range? It is u square. It is u square sin 2 theta by g. It is u square sin 2 theta by g. So this is the formula to calculate range. So read the question first. A football player kicks a ball at an angle 35 degree. So what is given? Theta is given. It is 35 degree. To horizontal with an initial velocity u. When I talk its initial velocity, it is given 15 meter per second. Assuming that the ball travels in a parabolic path, calculate. So what is the, you have to calculate? Assume that the ball travels in a parabolic path. You have to calculate. So your theta is given, your initial velocity is given, and to calculate, we know the value of gravity, it is constant, it is 9.8 meter per second square. So we know the value of gravity of earth, it's constant, g is equal to 9.8. So with these given things, you have to just substitute in the formula that we have derived in the previous slide, h max, time and range, and calculate what is the values. Do try to solve this numerical by yourself, where you already have a formula with the given parameters in the question. So with this, you have to solve the numerical. Next, you have uniform circular motion. So it's example for 2D, where we need x and y axis to describe the motion of the object. The motion of a particle along a circumference of circle with uniform angular velocity is called uniform circular motion. Consider a circle with center O. A body, an object is moving along the circumference of the circle. We know circumference is 2 pi r for circle. So body is moving in the circumference of circle. Initially, the body is at position A at time t. As it travels along the circumference of circle, it reaches the point position B at time t dash. So I'll draw this is the radius r. Now I'll draw a straight line from the position B to center O, and I'll name it as r dash. I'll join the straight line of the body at position B to the center O. It is also called axis of rotation. So the body is rotating at this axis of rotation, and r dash is nothing but the radius vector. A line joining the body, line joining the object from the position B to the center O is called radius vector. OB is represented by R dash, that is OB is nothing but the straight line that is joining the body to the center of the circle. Center of the circle is also called axis of rotation. So the body is rotating at the center of the axis. So OB is equal to R dash. So the angle defined by the radius vector at a given time interval is called angular displacement. Theta is angular displacement. So consider, what do you mean by that? The body is initially at position A. It is traveling along the circumference of circle. At T dash, it will reach the point B. It will reach the point B. A body is displaced from position A to position B. It is displaced. It is defining an angle theta at this point. So it is called angular displacement. What is angular velocity given by omega? Angular velocity is rate of change of angular displacement by time. What is velocity? Displacement by time. What is angular velocity? It is angular displacement by time. The rate of change of angular displacement by time, which is measured in radian per second, which is measured in radian per second. So what is angular velocity? Angular displacement by time taken. So what is angular displacement? It is the angle theta defined by the radius vector at a given interval of time. When a object is displaced from position A to position B, it is defining an angle theta to the center of circle. It is called angular displacement. So object is moving in the circumference of circle with uniform angular velocity. That is called uniform circular motion. It is moving with uniform angular velocity. That is why it's called uniform circular motion, or motion of the particle or a body along the circumference of circle, with uniform angular velocity omega is called uniform circular motion. What is the uniform circular motion? I have a circle. This is the center of the circle O. I have the body moving in this circumference of circle. Initially, it was at position A at time t. Now, it is displaced as time increases to t dash. It moves from A to position B. So, position B, and I have drawn a straight line from B to O, which is joining the body to the center O, which is also called axis of rotation, where the body is rotating. So this R dash is nothing but the radius vector. That is nothing but the radius vector. So a straight line drawn that joins the body, which is at position B, to the center O is called radius vector, given by OB. Line OB, that is R dash. The angle defined by the radius vector R dash, that is angular displacement theta. So what is angular velocity then? It is change in angular displacement theta by time taken, measured in radian per second. So next we have to derive a relation between, angular velocity, that is omega, and linear velocity v. How will you derive now? You have the circle. This is the circle. Body is moving along the circumference of the circle. The body is displaced from A to B. So I can write AB is equal to S, displacement of the body from position A to B. AB is equal to S. In the previous session we have learned this is nothing but the length of the arc. I can call AB is equal to S. It is nothing but the length of the arc. Now I know what is velocity, linear velocity. What is velocity? It is displacement by time. Displacement, I have taken it as S. Displacement by time. So what is S here? Displacement, I know. Displacement is also given by length of the arc. A, from the object is displaced from point A to point B. It is displaced from point A to point B. So AB is nothing but displacement S. I have taken displacement as S. So this is also can be read as the length of the arc. This AB gives the length of the arc. What is length of the arc? It is radius into angle. It is radius into angle. Radius into angle. I've taken it as small r. So substitute that here, S. So what is your V? It is length of the arc is nothing but radius into its angle. So it is r theta by t. What is r theta by t? What is theta by t here? It is angular velocity omega. So you can write V is equal to r omega. So you can see how it is related. Linear velocity is equal to r into angular velocity. Omega is angular velocity, V is your linear velocity. V is equal to r omega. What is the equation for linear velocity? Displacement by time. I have taken displacement as S. So it is S by t. This is also called length of the arc. How do you define length of the arc? Length of the arc, it is radius into angle made by it. R theta. Substituting the value here, I get V is equal to r omega. You can see linear relation between angular velocity and linear velocity, how they are related. So this is about uniform circular motion. Next, you have centripetal acceleration. Centripetal acceleration. I have already explained you. This is the center of the circle, axis of rotation of the body. So, object you can see it is moving in the circular path. It is moving in the uniform angular velocity omega. It is moving in the uniform circular motion. When it is moving with uniform circular motion, a body will experience an acceleration. A body will experience an acceleration along the radius vector at the center of the point O. At the origin O. When the body is moving along the circumference of the circle, uniform angular velocity, that is the body is moving with uniform circular motion, a body will experience an acceleration. Acceleration is a vector which gives both magnitude and direction. So it will experience an acceleration which is given by along a radius vector. It will experience an acceleration along the radius vector at the center of the circle. So that is called centripetal acceleration. So a body is moving along the circumference of circle with uniform circular motion. What is the condition for uniform circular motion? It should possess uniform angular velocity. So it's moving with uniform circular motion. A body or object will experience a acceleration along the radius vector or at the center of the point, that is called centripetal acceleration, the center point of the circle. This is called centripetal acceleration. We'll read the definition. When a particle moves along a circular path with uniform angular velocity, the acceleration will act towards the center. The acceleration will act experienced by the body along a straight line, along a radius vector is acting towards the center along the radius vector. So it is called centripetal acceleration. A body will experience acceleration. So it is to the center. Acceleration will act towards center when it possesses uniform angular velocity. When it is moving with uniform circular motion, the body will experience the acceleration acting along the radius vector, that is acting towards the center of the circle O. So expression for centripetal acceleration in terms of angular velocity, that is given as AC, acceleration with respect to angular velocity is equal to omega square r. So expression for centripetal acceleration in terms of linear velocity V, that is given by centripetal acceleration is equal to linear velocity square by radius, angular velocity square into radius. This is about centripetal acceleration. So in today's session, we already learnt about what is projectile motion. We discussed what is projectile motion, what are the components required to call it as a projectile. A path traced by a object is a trajectory. That trajectory is called as a parabola, and we proved mathematically that a path traced by the particle, that's the trajectory, is a parabola. Then we discussed 3 parameters: h max, maximum height, time of flight, and range of the projectile, through which I have given a numerical regarding a football. You have to try solving that numerical because all the parameters are given and the formula is clear in the derivations. Next, we discussed about uniform circular motion. If a body is moving with uniform angular velocity omega, it is called as uniform circular motion. Then we derived a relation connecting linear velocity v with angular velocity omega. V is equal to r omega. Then we studied centripetal acceleration. If the body is moving with uniform angular velocity, then the body will experience acceleration that is acting along the radius vector towards the center. So that is about centripetal acceleration. So that's all for today's session. Next, I'll come up with more interesting session on Newton's law of motion, the new chapter and new session. Until then, take care. Have a good day. Thank you.